Review questions, Chapter 6, Selected Word Problems. Problem 105, page 430. The floor of a rectangular shed is 7 feet longer than it is wide and has an area of 120 square feet. What are its dimensions? Let us let L equal the length, and from this statement, it is 7 feet wider than the width. Would become L equals 7 feet plus W. Area is expressed as length times W, and in this case, that value is 120 square feet. We can substitute the value that L is in the area, which will give us 7 feet plus W times W equals 120 square feet. We distribute and find 7W plus W squared equals 120. Then we will move the 120 from the right-hand side to the left-hand side by subtracting it, so that we'll get 0 feet squared in the right-hand side of the equal sign. Rearranging the terms, we have W squared plus 7W minus 120 is equal to 0. The standard form of the quadratic equation. We'll look for factors of a negative 120 that add up to 7, which is the middle term. And we'll find that it's positive 15 and negative 8. We can rewrite the equation now as W minus 8 times the quantity W plus 15. Now, in order for this statement to be true, W either will equal 8 or W will equal negative 15 or both. But we know that dimensions can never be negative. The real solution then is just the positive value, W equals 8. If W is equal to 8 feet, then 7 feet more than that is our length, which is 15 feet. Problem 109 on page 430. A box is made from a rectangular piece of metal with length 50 inches and width 40 inches by cutting out square corners of length x and folding up the sides. Write an expression that gives the surface area of the inside of the box. Let's recall that the surface area is the sum of the surface's areas bottom and the 4 sides. So we have to sum the area of the bottom plus the area of the short sides here and the area of the long sides here. So these 5 pieces will give us the total surface area of the inside of the box. For the bottom, we know that the length is, if we're going to cut out the x's on either end, the length will be 50 minus 2x. The width will be the 40 minus 2x. The bottom area's width and length will give us the area, so we'll multiply 50 minus 2x times 40 minus 2x. Using FOIL, we'll get the bottom area will be 2000 minus 180x plus 4x squared. The one short side's length is equal to 40 minus 2x, because x is being cut out of both ends, and the width of that will be x. The area of the short side, one short side, will therefore be 40x minus 2x squared, if you multiply the length times the width. Length times width. We'll do the same idea for the long side. This time the length will be 50 minus 2x and the width is x, so that the area is 50x minus 2x squared for the long side's area. We'll add up all those pieces, noting that we have 2 short sides area, and that'll be 80x minus the 4x squared. And the 2 long sides area is going to be the 100x minus 4x squared. The bottom will be 2000 minus 180x plus 4x squared, and the sum of all those will be, well, 2000 is just by itself. The middle term will disappear and become 0, And the negative 4x squared plus the 4x squared will just be negative 4x squared, and that is our surface area. For B, if the surface area is equal to 1,900 inches squared, we can plug this value as the value for the equation we got in A and set that to the surface area to find x. If we add negative 2,000 to both sides, we will get negative 4x squared is equal to 1,900 minus 2,000, which simplifies to negative 4x squared is equal to negative 100. When we divide negative 4 to both sides, we'll get x squared is equal to 25. When we take the square root, our solution should be plus or minus 5. But since it's dimensions and we know negative can't be part of our answer, we'll just take x equals 5 inches as the solution to set problem B.